Good evening. So, it's me again. I don't think I introduced myself before. My name is Shyam, Drury. I'm the maths multiplier here at SciTech, which means that I think my job title, my description is to increase the quality and quantity of maths programs at SciTech. So I get to do a whole bunch of stuff. Having people throw pie in my face for International Pie Day, going out to schools, working with teachers. And I want to talk to you a little bit about something I did in Portland, Victoria, with 5 schools out there. I ran some maths inquiry sessions, and just talk to you about what are the few of the key aspects of running a maths inquiry session, a little introduction to maths inquiry. So what is inquiry maths? Inquiry maths is a model of teaching that encourages students to regulate their own activity while exploring a mathematical statement or a prompt. Inquiries can involve a class on diverse paths of exploration or in listening to a teacher's exposition. In inquiry maths, students take responsibility for directing the lesson with the teacher acting as the arbiter of legitimate mathematical activity. It's a mouthful. This is taken from a website on inquiry maths. Basically, inquiry maths means the kids ask their own questions and then answer them. So instead of us giving them a hoop to jump through, we give them an opportunity to explore and learn through that exploration. So this is what I did in Portland. I walked into the class and I gave them all a sheet that looked like that. 3 rectangles, that's my prompt. And I said, what can you ask me about that? Actually, I asked them another question. I said, do you think there's much information in there? Like, no. And that was like a little hook for later when we came back. And I said, what questions can we ask about this? Where the class ended up in a whole bunch of different avenues that it took for different children. So I took a few photos. So this child has, he's calculating the area and the perimeter of different rectangles, and he's noticing that the area of the 3 different rectangles is the same, but the perimeter is different. This child went on a path of, he wondered how many of each of the rectangles do I need to fill that remaining graph space. So he did an exploration around that, about efficiency and packing. And this child was very interesting what he came up with. So he, after the observation that the area was the same but the perimeters were different on the rectangles, the question that some of the children asked, and kind of that I had in my mind of the thing to explore, was, are there any other rectangles that have the same area but a different perimeter? And the answer is no, actually, because these rectangles that I gave them, their area is 12, there's a 2 by 6, a 3 by 4 and a 1 by 12. They're all if you're familiar with factors, they're all the factor pairs of 12. So there's no other way you can make a rectangle that has an area of 12 perimeter, except he did. He did this. So he looked at the ways all the rectangles were the same, he broke them into 4 quarters, put them together to show their equivalence through this. So he's showing another principle there, the equivalence of the 3 different rectangles. And he said, yeah, you can make this rectangle as long as you leave a hole in the middle. So not technically a rectangle, but all of this is very interesting learning that comes out in inquiry maths. So there are 3, in my opinion, there are 3 key phases or aspects of an inquiry lesson. So the first one being students ask their own questions. The second, that they learn how to identify meaningful paths of investigation. So they learn how to differentiate the types of questions that lead them into exploration and the types of questions that lead them to dead ends or that are not relevant. And they learn how to investigate, so how to answer those questions, how to come up with answers to those questions they ask in a way that provides meaningful results and that they can prove their results. So that's the deeper, more technical part, the formalisation of their work. So this first one, students formulate their own questions for exploration. These are some of the questions that students came up with. So, why are the rectangles different colours? What is the perimeter? What is the area? What is the same? What is different? Are there any other rectangles that have the same area but a different perimeter? Can we make the rectangles into each other by cutting them up? How many of each rectangle is required to fill the space? When we join them together, the areas add together, but is that true for the perimeters? So there's just a few, there were more. And as I said, this one, that's kind of the one that I had in mind in terms of, oh, that'll be an interesting question. But then they came up with all these other ones. And this is what happens in inquiry, is that the students will come up with parts of investigation that you didn't expect. And then you have to be ready to go down that path with them. So that's lots of different questions. Obviously, to get to those points, the slides that I showed you at the end, those kind of deep investigations that they did, I didn't just say, ask me as many questions as you can. That wasn't enough. I started there, and then I helped them to separate the types of questions that they asked. So same questions, but here, split up. So these are the differentiations. The first differentiation they need to make is between non-mathematical and mathematical questions. So every time they posed a question, I would ask them the question, is that something you can answer with maths? So we had this question come up a few times. Why are the rectangles different colours? I asked that question, they're like, no, nothing I can do with maths to answer that question. So that stays out of the maths inquiry. It's not a bad question, it's not a wrong question, it's just not something for mathematical inquiry. And then we have fact-finding questions. So like, what's the perimeter, what's the area, what's the same, what's different? These are simple questions. They don't lead to deep inquiry, but they are the basis for inquiry. So they have to start. So they always start with these types of questions. And normally to get them into questioning, one of the ways that I would do that was say, what maths words can you say about this picture? So then I would start saying words like perimeter, area, shape, and then I'm like, so can you turn those into a question? And then, oh, well, what is the area? What is the perimeter? So these are some of the ways that I try and help them, because these are kids that have never done inquiry before. So that's one of the things I did. And then differentiating between this fact-finding and actual investigation questions. So they need to get to a question like this to really do an inquiry session, to really explore and learn the principles. But it was these questions that led them there. By looking at what's the same and what's different, they see that the perimeter is the same, the area is the same, the perimeter is different, and then they can ask this question about are there any other rectangles that have that same area, different perimeter. So I would stop them at a certain point and I would give them some stubs of questions to make that differentiation and say, okay, if you've just got fact-finding questions, I want you all to come up with this type of a question, the big question, an investigative question. So you can try to come up with a question that goes along the lines of, is it true that? So that's looking for underlying principles. Is it possible that? Or what happens if? And that way, they'd be able to come up with a deeper inquiry question, which then they could pursue. Okay, the last bit is that once they get there and they do that, then you have to teach them how to actually communicate that in a mathematical way, use proper communication and prove their results. Very quickly, no time to elaborate on this, but it's much deeper, this part. But the key skills in good investigation, they need to be able to explore specific cases. They must be able to make meaningful observations about similarities and differences between cases and distinguish patterns so they can use the patterns to make conjectures and then be able to prove their conjectures. Go here to find out more. It's an excellent website that has loads of example lessons, people's experiences of the lessons and their feedback. And yeah, that's me.